Assalamualaikum and hi everyone. Okay, so today we are going to explore a subtopic in chemistry, topic 2 to be exact, okay, about the atomic model theory. Okay, stay tuned. Okay, students, before we start, I'm going to let you view the learning objectives. Okay, after completing this module, you'll be able to identify the structure of an atom proposed by J.J. Thomson, Rutherford, and Niels Bohr. And you can also explain a little bit about the quantum mechanical model of an atom. Before we start, let us go back a little bit into the past and we talk about this great man. He's an English teacher by the name of John Dalton. Dalton was the first person to identify the presence of atom. Atom is basically a matter that is spherical and it cannot be destroyed nor created. But that's what Dalton says. He also said that atoms cannot be divided. And he said that the same element has the same atom. But we all know that's not really true nowadays because atoms can be destroyed and an atom can be created. The bombing of Hiroshima and Nagasaki in Japan by an atomic bomb made of hydrogen atom showed us that atoms can be destroyed. But today we're going to discuss about the atomic model theory proposed by J.J. Thomson, Ernest Rutherford, and Niels Bohr. And we're going to take a look into what the quantum theory says about atomic model. Okay, students, let's take a look into the journey of the discovery of the atom. Students, I'm going to play a video now, so let's watch this together. Stay tuned.
An atom consists of a nucleus that is composed of protons and neutrons. The nucleus is surrounded by electrons. Protons are positively charged particles. Neutrons have no charge. Thus, the nucleus of an atom is positively charged. Overall, an atom is electrically neutral because it has the same number of electrons as protons. Let's go through the journey of the discovery of the atom. J.J. Thomson was the first scientist to propose his model of the atom in 1898. His model suggested an atom consisted of a sphere of positive charge with negatively charged electrons embedded in it. In 1911, on the basis of the alpha particle scattering experiment, Rutherford proposed a nuclear model of the atom. According to this model, an atom consists of a small, dense, positively charged nucleus located at the center of the atom, while negatively charged electrons revolve in empty space around the nucleus. In 1913, Niels Bohr described a new arrangement of electrons in an atom to explain its stability. According to Bohr's atomic model, the electrons revolve rapidly around the nucleus in fixed circular paths called energy levels, denoted by the numbers 1, 2, 3, and so on. The maximum number of electrons that each energy level can hold is 2n squared, where n is the number denoting the energy level. Each energy level is associated with a fixed amount of energy. In light of Heisenberg's uncertainty principle and de Broglie's concept of the dual nature of matter in 1926, a new branch of science termed quantum mechanics was put forward. It takes the dual nature of matter into consideration. According to quantum mechanical atomic theory, an electron can only have certain specific values of energy. The exact position and momentum of an electron cannot be determined simultaneously. Only the probability of finding an electron at a position can be determined. Psi squared gives the probability of finding the electron at that point, where psi represents the wave function of the electron. An atomic orbital can be defined as the three-dimensional space around the nucleus within which the probability of finding an electron of given energy is maximum. There are many atomic orbitals for an electron. Every atomic orbital has some shape and energy associated with it. All the information about the electron in an atom is stored in its orbital wave function, psi. S, P, D, and F orbitals are different solutions of the wave function psi. You have completed this activity. Select OK to return to the menu and continue to the next activity.
So students, how was the video that you watched just now? Okay, the part where the quantum atomic model theory is probably a bit confusing because it's not really our level, but it doesn't hurt to know more, right? Okay, so now we're going to explore the different structures of the atom. Okay, here we have 4 different atomic models. In 1898, that's the atomic model suggested by J.J. Thomson. In 1911, that's the atomic model proposed by Ernest Rutherford. And in 1913, that's basically the atomic model proposed by Niels Bohr. And in 1926, the idea of quantum mechanical model of an atom is being published. So we're going to look into each of the atomic model and explore one by one. Are you excited to explore the atomic model with me? Because this is highly interactive and let's watch this. Yeah. Okay, I'm going to choose J.J. Thomson model of an atom first. Okay, so here we have 3 different atoms where we have the structure of a helium atom, structure of a carbon atom, and structure of magnesium atom. So I'm going to click with, so I'm going to go with the structure of a helium atom first. Okay, so if you can see here, there's the positively charged sphere and negatively charged electron. So basically that's what the atomic model of J.J. Thomson is. So let's click the component. So we can see what's inside. Okay. So it's just basically a sphere, yeah, a positively charged sphere with the negatively charged electron. And so basically, student, if you see, the amount of knowledge found at that time is limited, yeah, because it's back in the 18th century, so where we don't have sophisticated equipment. So let's look at the other 2 elements. Okay, structure of carbon atom. Okay, pretty much the same as positively charged sphere, and you have more electrons now. You can see that I think there's like 6 electrons, and we can look at the component inside. Yep. Okay, it's like open. Okay. So we have like 3 here. Okay, not much here. Okay, let's look at the structure of magnesium atom. Okay, so you have more electrons, yeah, and still a positively charged sphere. The component, I guess we're going to see something similar to carbon and helium atoms. Okay, it's done. Okay, we're going to go back. Okay, let's explore the atomic model of Rutherford. Okay, I would love to jump. Yeah, I know. Maybe you have the idea of like jumping from J.J. Thomson's model to Rutherford's model, or maybe Bohr first. Yeah, but I think we go like we're gonna go according to the timeline so that we can actually see the differences. Yeah, from one atomic model to the other atomic model according to the timeline. Okay, let's look at Rutherford. Basically, Rutherford and Bohr's model is not so far apart. Then this is like in 2 years. Okay. So we're using the same atom, which is helium, carbon, and magnesium. Okay, students, look at that. Yes, you can see something moving, okay? And there's like this blue dots and red dots and something green circling. Can you like take a guess on what is that? Yes, I hear you. Okay, the green one is probably electron because electron is the only subatomic particle that can actually move. Okay, let's do some showing. Yes, okay, you're right. Yeah, the electrons are the negatively charged electron and positively charged nucleus. And I'm sure there's proton there. Yeah, okay. Let's go back. Okay, we're going to click on the structure of carbon atom. Same thing again. Look at those green dots moving around. Yes, okay, since we've labeled it just now, so I guess that, you know already that yes, it is the negatively charged electron that's moving about, and the positively charged nucleus is still in the middle. Okay. Now we're going to look into the structure of magnesium atom. Okay, I'm not going to hide the label this time. And yes, you can see merrily the electrons are moving. Those are the negatively charged electrons, and positively charged nucleus is still in the middle. Okay, look at that. Imagine how active this atom is with the electrons moving around. Yeah. Okay, let's go back. Okay, now we're gonna look at the Bohr's model of an atom. Are you excited? Okay, I am because I think this is showing something just a little bit extra from the Rutherford's model of an atom. Okay, we're gonna look into helium first. Oh, just now we saw a show, the movement of electrons happily moving about. But now it's like more structured where look at the electrons are moving in like a certain pathway. Okay, let me show the label. The electrons, yeah, the negatively charged electrons are actually moving in its own shell. And the nucleus is still positively charged nucleus. Okay, so we're going to go back. Let's look at the carbon atom. Okay, this time you can see there's two shells, okay, the K shell and the L shell, okay, where the electrons are actually moving in its own orbit. Okay, beautiful. Okay, now we're going to look into the structure of magnesium atom. Okay, so now we have an extra shell, K, L, and M shell. And if you can see, the electrons are actually distributed, yeah, in a certain number, where at the K shell, you can see there's two electrons. At the L shell, you can see like 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and there's two electrons at the M shell. Yeah, okay. So, yeah, interesting. I'm going to go back. Okay, now we're going to look into the quantum mechanical model of an atom. Okay, it's the same thing. Okay, we're going to look into the structure of helium atom. Okay, so you can see here, it's still sphere in shape. You can see the movement of the electrons. You can still see the positively charged nucleus. But if we explore, okay, okay, how about we see the structure of carbon atom? Wow, what an amazing atomic model. You can still see the movement of the electrons, yeah, all around it, but you can see there's a certain shape to the atomic model of carbon atom. Okay, but we're not going to explore deeper in this because it's not required of the syllabus, but yeah, it's no harm to learn more. So I'm just going to click explore, okay, so that you can see what's inside. Oh, that's 2px orbital. That's beautiful. And they want you to explore further, meaning that they have taken, shell by shell, the orbitals. Okay. All right, so I guess we'll stop here. I'm going to go back and complete the exploration with the structure of magnesium atom. Okay, if you can see that the shape is different, yeah, from magnesium to carbon to helium. Okay, and if I click explore, okay, it's just 3 shells now. Look at that, all the shapes are all over. Okay, so we're going to go back. Okay, we've completed the exploration of the atomic model. So now I'm going to go back to the main menu. Okay. So let's assess your knowledge in this short exploration of the atomic model theory. All right. Follow the instructions to perform the assessment and earn points. You can try multiple times, but points are only awarded if you answer correctly on the first try. Okay, so let's make sure that we are correct at the first try. Okay. Question. Identify the atomic model shown on your left. So we have choice of answer of A, J.J. Thomson's model of an atom, B, Rutherford's model of an atom, C, Bohr's model of an atom, and D, the quantum mechanical model of an atom. So which is it, student? Can you give me a hint? Maybe A or B or C or D? A? Okay, let me try A, okay? Oh my goodness, it's correct. Yes, so I scored my first point. Thank you, students. Okay, let's continue the assessment. Identify the atomic model shown on your left. Is it A, J.J. Thomson's? No, because we have identified it just now. So it's not A. Okay, so we have either B, Rutherford's model of an atom, or C, Bohr's model of an atom, or D, the quantum mechanical model of an atom. So which one is it? It's moving, the electrons are moving in its own orbit. Which one? B. Do you think it follows? Okay, you sure? I'm gonna go with your answer B. Oh my goodness, I didn't get a point this time. No, it's not quite right. So I'm gonna go with my answer, which is C. That's right. Okay. All right, let's move on. Identify the atomic model shown on your left. Okay, we have identified A and C, and we're only left with B and D. Rutherford's model of an atom, and D, the quantum mechanical model of an atom. So, yes, okay, it's probably B. Yeah, okay, that's correct. Okay. And this is the final atomic model. So I guess we all know the answer. We don't have to read the question, and the choices of answers. The answer is very obvious. It's D, the quantum mechanical model of an atom. Okay. It's not rocket science, yeah. It's kind of easy. Okay. Now there's a different set of. So they gave you the atomic model, and they asked you to identify and select the atomic structure proposed by Bohr. Okay. Which one is it? Is it the top left, bottom left, top right, or bottom right? Yeah, I'm gonna go with this. My gut says so. Yes, correct. Oh, look at these sparkles. It comes out of the atom. That's amazing. Okay, select the atomic structure proposed by Rutherford. Yeah, it's either this too, I think. Cannot be that. Yeah. Okay, which one is it? Okay, so I'm gonna choose the bottom right. Sparkles, more sparkles. Okay, that's correct. Now, select the atomic structure proposed by J.J. Thomson. So obvious, the answer is Yes. Look at that. Beautiful sparkles. Okay. Finally, the quantum mechanical model of an atom. Correct. Yay! Oh, I scored 7 out of 8. Okay. Oh, that's my score. 87%. Oh, that's how much, One question I got it wrong and 13% gone. Okay. You scored well and you have completed the modules. Like, okay, to return to the menu where you can exit. Okay. So students, today I hope that you have completed the learning objective of today, which is to identify the structure of an atom proposed by J.J. Thomson, Rutherford, and Niels Bohr, and a little bit explanation of the quantum mechanical model of an atom. So students, you have completed the exploration of 3 atomic models by J.J. Thomson, Ernest Rutherford, and Niels Bohr. And also, you did take a look into the quantum mechanical model of the atomic theory, which is used currently today. So please do explore chemistry, continue to explore chemistry in the best way possible, continue to gain knowledge, continue to be more excited about chemistry because there's a whole new exciting world out there of chemistry for you to discover. So until the next video and the next lesson, bye bye. Take care.